was very, very easy. All right. Being a good teacher, let's start with a review. You don't need to copy it down. Just look at page one. So right on page one. Just copy down the question here, which is Mr. Gurbani scolded me. He said, I'd like to see blue color, not red. It's calming. So I'm going to write in blue. Again, guys, be polite, unmute yourselves. Okay, Mr. Jin, Mr. Ferguson, Ms. Savarano, unmute yourself. Savarano, you should attend office hours, damn it. Okay, let's get started. So is that a piecewise function?
Mm-hmm.
So we're going to break up the integral. So you can use one of these words. You can say split up the integral, break up the integral. For students that get confused, like Rama, I don't know where to start. Here, the lower limit is telling you where to start. So start at negative pi. If you look at the piecewise function, for values below 0, you have one function. Values above 0, you have another function. Negative pi is obviously a negative number. It's below 0. So we go from negative pi to
0,
which is the break point. And then which function? Top or bottom?
top.
So 3 minus 2 sine x dx operator plus
0 to 1.
0 to, look at the upper limit, 1. Which function?
The bottom.
X plus ex dx. We'll actually do the entire problem. Look down now. Look down. I'm walking you through it. Integral of 3
3x.
minus 2 integral of sine x.
Negative cosine x.
Can I make that plus? And then that's negative pi to 0 plus, look down, integral of x,
X squared.
x squared over 2, integral of ex,
Yes.
lower limit 0, upper limit 1. Let's just plug it in, look down. Guys, don't rush through the substitution. Many kids rush and make mistakes. 3 times 0 is 0, right? The 0. Cos 0,
1.
so is that just 2 times 1? Minus parentheses. First term,
Negative 3.
negative 3 pi, and then 2 cos pi. Guys, I encourage you to memorize it because it occurs so frequently. Cos pi is negative 1. And some of you already memorized it.
But if it's negative
But
pi,
negative pi.
Silly girl. Negative pi is same as positive pi. Think about it. Visualize. No, I'm serious. Visualize. I'm sorry, that's negative pi. Look at the board, please. This is pi. This is negative pi. Will you end up at the same spot?
Yeah.
Okay. So she's right. It's called negative pi, which is still negative 1. Okay. Plus, next is that 1/2 plus
E to the power of 1.
e
Mhm.
minus
1.
0. Write the 0 plus e to the power of 0, which is 1. Correct? It's smart to write the 0. Okay. Let's wrap it up. 2. Continue.
Plus 3
Plus
pi.
Plus 3 pi.
minus plus 2.
1. Plus 1.
Plus 2. Careful. And then plus
1/2
1/2 plus e
minus 1.
minus 1. And you can combine like terms here. Okay, I'm not going to do it, but and the rest of them you just copy down. Is that clear? Okay, let's move on. Right on page 2. Okay, in your notebook, just write on this guy. Okay, how do we begin the problem? It says find the average of f of x.
AB.
AV, average value, equals 1 over
5.
brackets, integral 0 to 5, f of x dx. Look down. So 1 over 5. And for the integral, should we examine the piecewise function? So for those of you who get it, lower limit,
0.
breakpoint,
4.
4. Okay, which function? 0 to 4 is below 4.
The first one.
The first one. Thank you. dx plus
Plus the integral
Integral 4 to 5.
4 to 5.
4 to 5, the breakpoint till 5. The upper guy tells you where to stop. 2x plus 1,
Yes.
dx, don't forget the operator. Look down now. I'll walk you through it. What you did not forget to bring down.
1/5.
1/5, very good. Okay, we're ready to integrate, so the integral symbol vanishes. 3, let me guide you. Integral of 1 over radical monkey.
Is 2 radical.
Radical 2 radical monkey.
Divided by 2.
Thank you. Divide by 2. Chain rule. Lower limit 0, upper limit 4. 2's cancel. Okay, integral of 2x.
X squared.
Thank you. The 2's cancel. Integral of 1.
X.
Lower limit 4, upper limit 5. We'll plug it in and then move on. 3 square 2 times 4
8.
plus 1.
9.
Therefore,
3 times 3.
3 times 3 minus 3 times
1.
1 plus 5 square plus 5 minus 4 square plus 4.
Mm-hmm.
Can we move on? Oh, okay, guys, just to be clear, so there's no confusion. This entire thing, oh, I want to be careful. This entire thing is with 1/5, correct?
Yeah. Yeah.
It's easy to think. Isn't it possible that you think the 1/5 only applies to the first expression?
Yes.
Correct? That 1/5 applies to the entire thing. Be careful, please. Okay, let's do a problem review relating to displacement. Right on page 3, please. Okay, let's jog your memory. Guys, come prepare to class. If there's something I say memorize, study, you need to master it before you come to class. Okay, who, if anybody remembers the definition for displacement?
Change in position of the object.
Thank you. It's a net change in position of the object over 1 to 3. So what's my notation?
S of 3.
X of v change in position. S of
Minus
v minus 1.
Which is
So, what's the question we should ask ourselves?
Is there a mismatch?
Is there a mismatch? Therefore, will net change kick in?
Yeah.
Yes.
Yes.
Integral
1 to 3.
V
S dash T.
S
dash of t show the what?
T
It's dash of t dt, which is just
V
V
d of t. So integral, I'm just ready to plug it in, yeah? So at this stage, now look here, at this stage, are we integrating or just plugging in?
We're integrating.
We're integrating. How's an integration simple? There's no confusion. It says integrate. It's like, yeah, we plug in and we integrate. Can we move on?
Yes.
Okay, the next part of the lesson is we're doing interpretations, okay? If you attended office hours yesterday, you got an advanced peek at the concept. So don't write this, don't write this. So I'm just going over basic interpretations. If you see the phrase change in, change means different, so it's f of b minus f of a. And backwards, conversely, if you see f of b minus f of a, that's change in f of x over a to b. If you see the expression average rate of change, please understand that's different from average. It says average rate of change. So that's msec. That's f of b minus f of a over b minus a. Conversely, if you see f of b minus f of a in red, that means average rate of change of f of x over a to b. And finally, if you see the expression average or average value of f of x, it's the integral formula. Or if you see that integral expression, it means average of f of x. This is a quick review. Now let's discuss units. Right on page 5, interpretation and units. Now we're actually doing examples. Write down, we're on page 5.
Okay.
It says interpretations and units. So write down f of b minus f of a is the change in f of x over a to b. Write that down. And then write down your notes. Write down your notes. It'll have the units of f of x. If I say what's the change in temperature, can you see? You'll just say Fahrenheit. You're not saying Fahrenheit per minute. You're not like weirdly changing it. So please make a note. The units will just be that of f of x, whatever the function is. If we give you temperature, it's Fahrenheit or Celsius. If we give you weight, then it's pounds or kilos or whatever. Okay. So keep that in mind. All right. Now in your notebook, just write down this. Okay. We're going to interpret, write an English phrase. Do this with me. So it says A of 12 minus A of 0, where A of t stands for the acceleration of the object measured in meters per second square. So we will write an interpretation with the units. Okay, go. So what does that expression remind you of?
Changing.
Net
Changing.
change.
It's the net change in
Acceleration.
acceleration of the object not keeping good habits in. Okay, what would your units be?
Meters.
Meters per
Meters.
second.
There you go. It's just that function. It's meters per second square. Over the interval
0 to 12.
0 to 12, and that is measured in seconds, correct? That's time. Okay, I'm giving you the units. I'm giving the units of that interval. It's time, so it's seconds. It's that easy, guys. It's that easy. Interpret literally. You don't have to say, oh, that's average. But where is average coming from? It just says A of 12 minus A of 0. Let's do another example. Write that expression down. Okay, read the rest of the sentence. You understand what the context is. It's a little weird, but that's okay. So R stands for the rate of change of the population of mice in a culture measured in mice per hour. Okay, so that expression reminds you of
Net change.
net change in the
Rate of change.
thank you, rate of change. Very good. Rate of change of
The population.
population of mice. Don't be lazy. In a culture measured in
Mice per hour.
mice per hour. It's just the same units. You don't have to overthink it. Over the interval,
5 to 10.
5 to 10
units,
hours.
hours, the time is measured in hours. It's that easy, guys. Okay, let's do the next set of interpretations. Right on page 6. So it says, if you see the expression, write it down, f of b minus f of a over b minus a. It is the average rate of change of f of x over a to b. Now pay close attention. We went over this yesterday during office hours, but I'm repeating myself. Can you see m sec is actually a rate of change? So it's the derivative. So the units will be the derivative of f of x. Write that down. So this is the only weird guy. The others are straightforward. But this is the only guy that you have to be careful with the units. This is like m sec, m tan. They're slopes. So you have to give me the slope derivative. Sorry, slope unit. Relax, it's easy. Okay, in your notebook, write down this expression. So we're going to interpret it using English. Do not, oh, by the way, there's a typo. That's supposed to be S, right? I have to fix it. That's page, is that page 6?
Yes.
Yes.
Thank you. Okay, do this with me. So that expression reminds you of,
Average rate of change.
thank you, average rate of change. Do not overthink it. Which function? Of
Position.
the position. S stands for position. Position of the object. Okay, let me model good behavior. In, stop. Think before you answer. What would the units be? Hint, we just learned for average rate of change, it's the unit of the, it's the unit of the derivative. And
Velocity.
the derivative of position is
Velocity.
velocity. So what should the units be?
Meters per second.
B.
Meters per second. Okay, I should have said S in meters, correct? So meters per second or kilometer, whatever. So it's meters per second. And then over the interval,
4 to 14
4 to 14.
4 to 14
seconds.
seconds. Okay. Okay. Let's do another one. Copy it on the bottom, guy. So let's write the interpretation. It is the
Average rate of change.
Average change.
average rate of change of
The
Population.
Population of mice.
Of the rate of change.
thank you. Is it in the function R, which is rate of change? Is the average rate of change of the rate of change? Careful. It didn't say P, it said R, correct? The rate of change of the population mass. Be attentive, please. In a culture. Okay, now stop. Now, R is measured in mice per hour. So if you're attentive to the lesson, what would the unit be?
Mice per hour square.
Thank you, mice per hour square. Because of the derivative. Let's wrap it up. Over
5 to 10 hours.
hours. So pay close attention. The only tricky unit is where you see MSEC. Is that clear? Because MSEC is the slope. So you're finding the slope of R from the first chapter, first semester, mice per hour square. Okay, last interpretation, right on page 7. So it says 1 over b minus a integral a to b f of x dx. Write down your notes. It's the average of f of x over the interval a to b. And the units is very simple. It's just f of x, just like net change. It's just the unit of f of x. Do not overthink it. So if I said, what's the average weight? You just give me 150 pounds. Do not say 150 pounds per hour, something weird like that. Whatever the function is, it's just that in units. Okay. All right, let's do a couple of examples. Copy down the expression. Okay, go. It is the
Average.
Average.
oops, sorry. It's the average
Of velocity.
of velocity. Guys, do not overthink it. Don't say position, don't say acceleration. Where are those coming from? It's average of the velocity function. So average of velocity, or the average velocity of the object in
Miles per second.
miles per second over the interval
2 to 6.
2 to 6
Second.
seconds. It's that easy. Okay, for independent practice, do this all by yourself. Go left to right, observe what R stands for, write an interpretation with the units. Do this independently. Do not be sitting idly. Okay, soprano, have a shot. The soprano?
Denotes the average rate of change.
Again, silly girl, are you even paying attention? Why are you writing average rate of change?
Oh, the average.
Why? Why are you writing average rate of change? Does this remind you of the MSEC formula? Why are you writing average rate of change? Where is that even coming from? You don't. We learned 3 interpretations. We did average rate of change, which is the MSEC formula. Net change, which just means difference. And then you have an integral, that's the 1 over b minus a integral, that's average. Okay, it is the average of.
The amount of fruit.
No. Okay. Okay. I think I understand. Okay. You were missing the word average. Otherwise, you're okay. So it's the average of.
Wait, I'm lost now.
No. It's the average of.
The amount of fruit.
No. There is no amount here.
Oh, denotes the rate of change.
The rate of change. I wanted that word off, silly.
Yeah.
Guys, before I move on, I want you to understand my confusion with what Ms. Sobrano said. She's not incorrect. Okay, so she said average rate of change. Do you understand why I might be thrown off?
Yeah.
Oh.
Correct? So it's the average of the rate of change. Now, if you do not write the word of the it will not mark it down. You would confuse students, confuse us if you say average rate of change. It's the average of the rate of change of the amount of fruit on the shelf. of a store. Subrana, what's your units? In,
Pounds per minute.
again, it's just the units, guys, of hour. Over the interval,
1 minute.
minutes. Is that clear? Was that easy?
Yeah.
So let's go, guys, pencils down. So which is the only one that has slightly confusing units out of the three? So we did net change, average rate of change, and average. Which is the only guy that you have to be careful about units?
Average.
Average rate of change.
Average rate of change, because the average rate of change is a slope. You have to give me the slope of that function. Just be attentive, okay? Let's do a mixed review. Right on page 8. I'm mixing it up now. Okay, so we did discuss two of each kind. Being a good teacher, now I'm mixing it up. Okay, in your notebook, just write on that expression.
What page?
Okay. Sorry, we're on page. Guys, we're on page. Your mom. Sorry, page 8. We're on page 8. It's a Rama classic. Okay, we're on page 8. Write on that expression. Okay, I'll give you 3 options. Choose wisely. Do not speak for 10 seconds. Those of you got the hang of it, you can run ahead. So, is that average? Is that average rate of change or net change? Don't speak. Okay, Mr. Hernandez, which of those 3 is it?
Average rate of change.
Love you, man. So it's the average rate of change. Let's start writing down. So it's the average rate of change because it reminds you of the unchecked function. Of Hernandez, of the,
Of the volume of water in the
there
tank
you go. Get it from the question. The volume of water in the tank. In what are your units be?
in gallons.
Ms. Gatsella?
Gallons per minute.
Okay, Mr. Hernandez, don't forget. Average rate of change, you give me the units of the slope. So it's gallons per minute. Over the interval,
50 to 100.
minutes. Okay, check if we got that. Miss Julian, you're doing okay?
Yes, I'm doing.
McQuarter, please attend office hours. I missed you yesterday. McQuarter. That girl. Sorry, what did you say?
I said okay.
Okay, guys, let's do another one. Copy down the next expression. Now I'm checking how many of you have good memories. Okay. First of all, do we have? I'm just checking the good memories. Anybody remember what that guy reminds you of?
Average.
No, it is not average. You don't have a 1 over being manager.
Displacement.
Displacement. She's coming prepared to class. It's the integral velocity displacement. But otherwise, I'm showing you a trick. Otherwise, who said displacement, by the way?
Miss Holdenauer.
This who?
Miss
Foldenauer?
Mhm.
Okay, good girl. Love you. Guys, she remembers the integral velocity is displacement. But otherwise, for the rest of the kids who are not as prepared, can you see we don't have an interpretation? But smart kids, we can write V of t as dash of t. So you're learning a concept. If you do not know an interpretation, rewrite using that change. Therefore, the right-hand side becomes
S of 5 minus S of
S
2.
of 5 minus S of 2, which reminds you of which interpretation?
Net change.
Net
Net
change.
change.
Position.
Position. It's a velocity. It's S. So it is the net change. We'll write 2 definitions. So it's a net change in position. Or, as Ordonez smartly said, it's the displacement. You can write both on the AP exam. Of the object in, what do the units do? In its position or displacement.
Meters over minute.
No. We're writing the units of position.
Oh, it would be just meters.
Just meters, okay? Not the original. The meters per minute is velocity. We want this thing for position, correct? In meters over the interval
2 to 5.
40 minutes.
minutes. Exactly. Yeah. Okay, do the last all by yourself in different practice. Write me the units also. I mean, no rush. Okay, Ms. Meena Hamstrong.
Average number of attendees at a convention in hundreds over 3 to 15 closing interval.
Hours. Okay, guys, you may not you may not have heard her. I have super sharp hearing. That was Meena shouting, by the way. All right, that was Meena being super excited and shouting her head off. So I'm doing gentle teaching of this Meena. This is Miss Meena on an amusement park ride. Guys, this is Meena not even in Disneyland. This is Meena in Six Flags. This is a big park ride. Okay. Oh, Miss Meena, how are you finding the ride? This is Miss Meena. Yay. Yay. That's Meena really excited and shouting her head off. So see, I'm just teasing Meena. It's the average number of attendees at a convention. In hundreds, that's the unit. Over the interval 3 to 15 hours. Okay, not easy. Definitely got that yourselves. Right. We do the others if you attend office hours. We do more examples. I have lots of examples. Okay, let's do problem setup. We're doing a mixed review for the next 10-15 minutes. Write down page 12, please. Mr. Buhe, how are you doing?
Good.
Okay. Guys, this is page 12. So copy down this. And then copy down that. So you know what the question was. Okay, first step, I'm giving you good habits. Interpret the problem exactly the way it's written. Do not overthink it. Interpret it literally. Okay, Ms. Vasquez, have a shot. What do you write? Ms. Vasquez, unmute yourself, please. Vasquez, are you there? Okay, Ms. Carlos, pick it up.
S of pi over 2 minus.
It says average rate of change of position. So Ms. Carlos smartly says S, pi over 2 minus S of 0, all over
2.
pi over 2. Stop. What's the question we should ask ourselves?
Is there?
Is there a mismatch? Okay, is there a mismatch?
Yeah.
Yes. So net change will kick in. See, this comes back to you. Can I pull out the 1 over pi over 2?
Mm-hmm.
Okay. All right. Ms. Carlos, continue. What are you writing in parentheses?
S of pi over 2 minus S of 0.
No.
Wait.
You're not writing S of pi over S of 0 again in parentheses. You should apply net change. How does net change work?
Oh, the integral?
Yeah.
Oh,
Integral.
yeah. Integral from 0 to pi over 2. And then S dash 15.
There you go. What are the use of the if you just copy it down twice? It's not moving you on. You just S of pi over minus S of 0 again. How is that helping? Okay. Ooh, guys, what is S dash in front of you? V of t. And do we know V of t? By the way, 1 over pi over 2 becomes
2 over pi. 2 over pi.
Multiply by the reciprocal. Integral from 0 to pi over 2. Copy down. Okay, we will only integrate, we will not plug in. Okay, D2, don't forget the operator. Okay, Mr. Buhe, have a shot. What's the integral of sine t?
3 times negative cosine t.
You mean 3t? Is it 3 times?
Oh no, divided by 3.
So negative 1/3, right?
Yeah.
Okay, do the other one. So
Minus 4e to the power of negative 2t divided by negative 2.
okay, guys, be careful for integrals you're dividing. Okay, low limit 0, upper limit pi over 2. Can we move on? Okay. Guys, I'm focusing on the important idea, which is setup. Correct? Can you see setup is the challenging one? Okay, right on page 13. Okay, do the first step yourself. Interpret the problem literally, exactly the way it's written. Not overthink. Okay, Ms. Bishop, have a shot.
AV equals 1/7, 1/8, sorry.
Continue.
1/8 bracket integral lower limit 3 upper limit 11 v of t dt.
Again, it says average velocity. Very good, Ms. Bishop. Interpret literally. Do not overthink it. Don't say S of t. Where is S coming from? Is this average velocity? Guys, is there a mismatch?
Yes.
Yeah.
Yeah. So we write V of t as
S dash
S
of
of
t.
S dash of t. Okay, write me the right side yourselves. Write me the next step yourself. Go on. Okay, Ms. Sarango, what are you writing?
1/8 bracket integral 3 to 11, and then would it be? This was the one I messed up on yesterday. Would it be S of 11 minus S?
No, guys, when you're going from one form to another, everybody look at the board. Everybody look at the board. Everybody look at the board. So look at the previous problem. It said S of something minus S of something. So when you're going to the other form, you have integral. So look at this problem. We have an integral. So when we're going to the other form, you cannot write the integral. The integral should vanish. Okay, again, next chain says if you have integral of a derivative, then it's the function itself, upper limit minus lower limit. So do not write the word as integral again. That'll totally confuse you. Okay, go on, Tarango. Start again. So 1/8.
1/8 would it be S of 11 minus S of 3?
There you go. Don't say integral.
My bad. I meant to because I was gonna do something else, and I was like, wait, this was the one I messed up on yesterday. So I remembered.
Okay. Guys, is there integration involved or just substitution?
Substitution.
Okay, just they give you S of t. Can we move on? You just have to plug in S, sidebar S of 11, S of 3, plug it in, simplify. Don't forget the 1/8. Okay, go to page 14, please. Okay, interpret the problem literally, exactly the way it's written. Do not overthink it. Okay, Ms. Makwara, have a shot. How do we interpret that phrase? Do not overthink it. We can't hear you, Makwara. You have to be louder.
We do the V of 3 minus V of 1.
Love you. V of 3 minus V of 1. That's it. Guys, do we have a mismatch?
Yes.
Okay, Makwara continues. So what are you writing on the other side?
And then that it's mentioned. So is it integral?
Yes.
Yeah.
Guys, if you have a difference on one side, the other side becomes an integral. If you have an integral, then you have a difference on the other side. Ms. Sarango, observe the pattern. Okay, continue, Ms. Makwara. Integral.
Of 1 to 3. And then V dash of
Yes, V dash. Take the derivative. Guys, what do we know V dash as?
AFT.
AFT. So can we plug it in? Does this question require integration?
Yes.
Yes. Because it has an integral symbol right now. Okay. Okay, guys. Now I'm showing you how to do a bunch of problems. We went over this in office hours yesterday, but we are doing a bunch of problems involving a calculator. So in today's homework, you'll clearly have a C next to it saying you're allowed to use calculator or Desmos. Write down page 15, please. Everybody, stay with me. Write down page 15. Now I'm informing you you're allowed to use a calculator. And I will just guide you. Most of these are stupidly simple, but the harder ones we'll actually do in Desmos. Okay, copy down this question. We need to accelerate. Okay, stay with me. Okay, stop. What do we ask ourselves first step?
Sir,
Is it a mismatch?
Is there a mismatch?
Yes.
Yes.
Okay, so give me your right hand side. Look down. Do not speak. Okay, Mr. Rango, what are you writing?
Would it be f of 2 minus f of 5? Wait. Wait.
Other way around.
No, f of 5 minus f of 2.
Yeah, upper limit. Oh.
Thank you for remembering that.
Stop. Do we totally have f of x?
Yes.
Okay, now pay attention. We're not doing it, but pay attention. Can you type that in Desmos? And then in the next row, just type that.
Yes.
Yes? You don't have to do them separately. Type the original guy in Desmos in row 1 and just type f of 5 minus f of 2. You're good to go. Is everybody okay there? It's a stupid problem. Okay, let's move on. Right on page 16. Now we will actually do this in Desmos. So pay close attention. We will actually do this in Desmos. Okay, copy that, copy that, copy that. Okay, those of you coming prepared to class, they're giving you f dash, they're giving you a starting value f of 4 equals -1. The question says find f of 0. So what concept kicks in?
Net
Change corollary? Okay, we're using net change corollary. So f of 0, so whichever the question is that we're finding. So f of 0 equals
F of 4
f of 4.
plus
Integral, pay attention. This is the lower limit.
4.
We go from-
4 to 0.
Is it tempting to write 0 to 4?
Yes.
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 But you need to slow down and think through the pattern. And the guy we need is on the top. F dash of x dx. Is everybody okay there? Okay, now can we plug it in? What's f of 4 given to me?
-1.
-1 plus integral 4 to 0 f dash of x, and you can plug it in. But I'm going to leave this as, say, f dash of x. I want to show you how to do this on Desmos. Okay, follow my lead. Follow my lead. I'm going to go, let's see if we can present here. Okay. I want you to open a new window. Go to Desmos. Okay, is everybody able to see my screen on Desmos?
Yes.
Okay, now I want to show you. Now I did not teach this to the other class this way. I'm showing you how to do this. So type f of x. Pay attention. I'm just typing that as f of x. Is that clear? I'm not typing f dash. I'm just calling it f of x. Play along. So f of x equals x over 2 times sine e to the power of x. Is everybody okay there?
Yes.
And then in the second row, I will just now look at the expression. Is that -1 plus integral int? Repeat, the command is int. Lower limit,
4,
upper limit.
0.
And should I just type f of x dx? Does everybody understand why?
Yes.
Dx. Ta-da! Write down your answer. -1.0516. Do not forget to type -1 plus. So -1.0516. Is everybody okay there? So type the function as just f of x. Now in the other class, I had them type out the entire expression. Okay, I'm showing you what we did in the other class. In the other class, I showed them write down or. we just wrote -1 plus integral 4 to 0 x over 2 sine ex dx, and the other class typed out this entire thing. Is it easier to just type f of x integral f of x dx?
Yeah.
Yeah.
Correct? So I'm switching. Just call the original function. I know it says f dash, just call it f of x, and then just type it. Okay, let's do another example. But we'll do a harder one. Now, informing you, you have one question each time. So page 16, you write an asterisk. Page 16, you have a question like this on your chapter test. And then page 17, you have another question just like page 17. I'm informing you. And B, observe how dedicated a student Abdul Rahman is. She's making notes to herself saying, oh my God, these are important questions. I'm informing you that page 16 and page 17 are questions on your chapter test. So write on page 17. Relax, we'll get multiple opportunities of practice before we take the test. So copy that down. So this time, just like first semester, we're finding the
Equation.
equation of the tangent line to f of x. This is page 17, please. And x equals 8. Okay, relax. It's a stupidly easy problem. The calculator is going to do all the hard work. Okay, I need the equation of the line. What are the two things we need to write the equation of the line?
A point.
Point and slope. I hope you wrote down all the information given to us. So point, the notation. What's the x value of the point?
8.
8. The notation. What do I need? Notation. I need 8, comma,
1.
F of it?
Y.
f of 8. I love you. F of 8, silly. That's f of 1 equals -2. That's just a random point given. I need the equation of the line at x equals 8. So isn't 8, comma, f of 8. Does everybody understand that? Oh! I know f of 1. I need f of 8.
Corollary.
She's having trouble pronouncing it. So are we using net change corollary? Again, so we know f of 1. I know f dash. I need f of 8. Make the connection, please. So f of 8 equals
F of 1.
f of 1
Plus.
Integral.
integral
1.
Yeah.
dash of x dx. Is everybody okay there? So what's f of 1 given to be?
-2.
-2.
-2 plus integral 1 to 8 f dash of x dx. Remember, we'll use Desmos. Okay, now I want all of you, switch to Desmos, type out first, f of x equals radical x sine of x squared over 4. No, you're not sitting idly. Guys, I'm going to accelerate now. Hurry up, you should be working on this. Quick. So type out Desmos, clear the old guy. Top row, f of x equals radical x times sine of x squared over 4. Then type this entire expression. Be smart. Don't type f dash of x types because the function is f of x. Those of you finished, what is the function? Give me the point. Quick. I need everybody to work. Do not be sitting idly.
I got 0.2095.
Somebody confirm that.
Yeah.
Thank you. So I'm being a good teacher. So you have basically 8, 0.2095. Is everybody okay there?
Yes.
Next, we just found the point. What else do I need? I need the equation of the line.
The slope.
Okay, what's my notation? What's my function notation? It's without a trick.
F double dot.
Dash.
Is that f dash at 8? Is everybody okay there? I need f dash at 8. Stop! What do they give? What do they give you?
F dash of x.
F dash x. So what do I just need?
Plug in 8.
Plug in 8. So when you know in your Desmos,
Plug it
haven't we already called that function f of x? So in simple language, do I just need f of 8 then?
Yeah.
Okay, and if you're not able to make the connection, everybody look at my arrow. That's f dash of x. I just need f dash of 8. I'm just going to plug in 8 there. So have Desmos do it. Tell me what you get.
Negative 0.814.
Somebody confirm that.
Yeah.
Okay, guys, just to be clear, in Desmos, am I just typing f of 8 or f dash of 8? Which one am I simply typing?
F of 8.
F of
F of 8, because the original function was f dash. Be alert. Okay, is anybody confused or lost? This is the time you tell me. Carlos, are you understanding what's going on?
Yes.
Miss Meena?
Yeah, I am.
Miss McQuarter?
Yeah, I'm kind of getting it.
Miss Bergen?
Yeah, I'm getting it.
Okay, final step. Guys, we're writing the equation of a line. So how do we always write the equation of a line? Let me guide you. Y minus
Y minus
0.2095
equals
equal to negative 0.814 x minus 8.
ta-da! It's that easy. It's that easy. So before we leave, observe why this question was slightly more interesting. I needed a point and a line at 8. Some of you are focused on the 1. I don't care about the 1. I need the equation of tangent line to f of x at x equals 8. So we find the point, which is 8, comma, f of 8. Ooh, net change corollary. Yeah, tricky question. Then I need the slope. They give you f dash. Okay, I can just plug it in. And we're good to go. Okay. Back to page 18, please. Okay, we'll set it up. Ms. Uduman, tell me what to write.
AV
Equals,
1/4
very good, 3 minus negative 1.
integral -1 to 3 f of x dx.
Everybody, look at the board, please. Is there a mismatch?
No.
No. Are we just good to go? Are we just good to go?
Yeah.
This is me showing you not every problem is there a mismatch. Can we just plug in? Oh, by the way, it's just a calculator problem. So is it stupidly simple?
Yes.
You can just type f of x and then just do integral 1/4 integral -1 to 3 f of x dx and you're good to go. It's just a calculator problem. Okay. Let's do another one. Right on page 19. Stay with me. Do not fall behind. Morales, are you having better work habits? Are you keeping up with your homework? Every day?
Yes. Yes.
Good girl. Okay, guys. We're doing 19. Stay with me. Okay, Vasquez, are you there? Vasquez, are you there? Okay, forget it. Oh, you're there now, finally. Okay, Vasquez, if you interpret the problem exactly the way it's written, tell me what to write.
The average rate of change. So wouldn't it be f of 3 m-sec equals f of 3 minus f of -1 over 4?
Okay, everybody, is there a mismatch?
No.
No. So it's just stupidly simple. Okay, I know this is from the first semester. Everybody, I'm teaching you good habits, girls especially, because I love you people. I'm showing you how to type this on a calculator. Everybody, see this comes back from the first semester. When you're typing the decimals, can you please make sure you have a parentheses there? So PEMDAS, order of operation, fix it. Yes? Okay, we're not going to do it. I'm just showing you. It's a stupid problem. But make sure you put parentheses on top. So order of operation, fix it. Okay, next. Right on page 20. Now you have a whole bunch of these problems on your homework. Ms. No said the homework is insanely easy. Okay, Miss Julian, have a shot.
Average rate of change equal f of 4 minus f of -1 over 5.
Okay, Miss Julian will stay with you. Do we have a mismatch?
Yeah.
So tell me what to write next. Yeah.
So do we write integral? And is it -1, and then f dash of it. Yeah.
Guys, see if this comes back. Should we pull out the 1/5 like this?
Yes.
Yeah, good habits. Pull out the 1/5. Okay. Can we now just type that in the way we see it on your calculator on Desmos?
Yes.
And we can call this f of x, right? We can just call that f of x and type that in. Yeah, everybody okay there? Okay, just call that f of x. Type that in. We're good to go. Okay, now we're learning something brand new. Okay, right on page 21. Everybody, page 21. You do not need to copy the table. Do not copy the table. Just write down that expression. It's a stupidly easy problem. It says use the table to find the value of. We have discussed questions like this before. So if I say in the future, because you'll have a question like on your test. If I say in the future, how do we do this? You will, just like a piecewise function, you'll say, you'll use a magic phrase, Rama, split up the interval. Okay. You'll say split up the integral and you get to go. We have done this for limit problems, we've done this for derivatives, and we're doing this for integrals. I'm going to write something on the board, look at it and say, oh, yeah, this comes back to me. So I'll do the first term, you guys follow the other one. So I'll pull out the 2, I'll just distribute the integral. 3 to 7, h double dash of x, dx. Okay, go. Tell me what to write.
1.
Oh, it's h dash of
1 second.
-3 integral. And then h dash of x.
Dx, don't forget the operator. I'm just splitting up that integral. And then for the last guy, just number 4. So that's just 3 to 7, 4 dx. Is everybody okay there? I just split up that integral. Okay. 2, stop. I have to find integral of h double dash. And the graph, the table gives me h and h dash. So in simple language, there's a mismatch. So smart kids, what can I write? Integral of h double dash. Tell me what to write.
it's h dash of the 7 minus h dash of 3.
Is everybody okay there? Using net change. Next, I need the 3 to 7 integral of h of x. I do not have an integral of h of x. Therefore, I can write integral 3 to 7 h dash as.
H of 3, or h of 7 minus h of 3.
Is everybody okay there? Net change again. Plus, smart kids, don't get lost. 4 is just a constant. What's the integral of 4?
0.
4x.
Perfect.
Correct.
We're doing integrals. 3 to 7. Okay, let's wrap it up. Ooh, read the table. What's h dash of 7 given to me?
10.
Minus h dash of 3.
5.
Very good. Minus 3. What's h of 7 given to me?
22.
22. Minus
7.
7.
plus. Okay, now we are plugging in upper limit. 4 times 7.
28.
Minus.
12.
Ta-da! Was that stupidly simple?
Yep.
Okay, so I was showing you how to apply net change using a table of values, and that's okay. Okay, right on page 22. Everybody right on page 22. Okay, I'm letting you know this is the new bulk of the lesson. Okay, moving forward, 10 to 10:30, we're doing brand new stuff. So pay very, very close attention. Okay, push your pencils down. It's a word on. So I'm going to direct. If you were here, kids, if you were here during office hours yesterday, you got an advanced speak of the problem. I love you kids who attend office hours, even when it's not your day, because you're getting an advanced speak of the problem. Okay, read it with me. This is from the first semester, but I'm emphasizing a concept. Read it with me. The amount of shrimp. Oh, by the way, that's page 22, by the way. Okay, the amount of shrimp at a restaurant buffet is changing at a
Right.
rate of R of t in pounds per minute. Stop. From the first semester, and we have a word problem, and we have a rate. Who remembers how we set up these problems?
80.
Let A of t, I love you. Let A of t be the
Amount.
amount of shrimp. At the buffet at time t. And the amount would be measured in pounds, correct? Who remembers what we wrote next step to set it up still?
A dash of t. Which
A dash of t is nothing but
The rate.
R of t. We just sine of e to the power of t over 2. They're giving you that. And is that the rate of change? See if this comes back. It's there on today's homework. So I'm making I'm tying up a concept from the first semester. Rate of change of the amount of shrimp. And that's measured in pounds per minute. Okay. Now read on with me. I'm putting a bracket so you can focus. It says initially there are 20 pounds. Look at the units. If initially there are 20 pounds of shrimp in the buffet. So what are they giving you indirectly? If initially there are 20 pounds of shrimp.
AT.
A of 0.
A0.
Love you. A of 0. The time is 0. Initially means time is 0. Equals 20 pounds. Is everybody okay there? And now, let's read the last sentence. Find the amount of shrimp at 3 minutes. What are they asking for in notation? A of 3. Is everybody okay so far? Okay, because I'm aspiring to be a good teacher, I want you to read the paragraph and look at what we wrote once by yourselves. Give it 30 seconds. Do not speak. I'm in no rush. Feel free to ask me clarifications. So the question says the amount of shrimp is changing at a rate. You say, hey, wait a second, word problem with rate. Set up the original function. Let A of t be the amount of shrimp. So we see the word number, volume. It's just amount. Just say amount. Population. Those are all amounts. So let A of t be the amount of people, the amount of water. Then A dash of t is R of t. Is the rate of change. A of 0. Initially there are 20 pounds. A of 0 is 20. Find the amount of shrimp at t equal. Oh, they give you a starting value and they give you a derivative. So what can I do?
Net change quality.
Net change quality. A of 3 is
A of 0.
A of 0.
Integral 0 to A dash of t.
Oh, what A dash after all?
R of t.
R of t. And A of 0 was 20 pounds. Can I totally use Desmos to answer the question?
Yes, sir.
Do we need to do it? Or you guys say, yeah, we're okay?
We're okay.
We're okay. You can just type R of t in row 1 and just type that in 20 plus 0 to 3 R of x dx. Everybody okay there? Guys, make sure old rules. Type it as R of x dx. Yes? I hope that comes back to you. Okay. Let's do another problem. Actually, we'll skip this. We'll come back to this. Okay, we'll do this just for interpretations. Okay, go. This is page 25, please. Everybody, page 25. Actually, guys, we'll come back to this later. Okay, actually, right on page 27. I'm so sorry. Right on page 27. Okay, I want you to make a quick sketch. Here's how you make it quickly. You just go from 0 to 6, and the lower guy is 3, -3. And then at 3, you go from 6 to 8. From 6 to 8, you have a line at 3. Just make a very quick sketch, like a 30-second sketch. It doesn't have to be precise. A semicircle from 0 to 6, and then a flat line from 6 to 8. And the operative numbers are 3 and -3. Again, it should literally be a 30-second sketch. Okay, now let's do it together. What should I label the graph? Read the first line. Everybody read the first line. What should I label the graph?
VT.
Thank you. That's the velocity function. So it says V of t is given by the graph below. If S of 7 equals -5, write that down. Everybody. They're giving you S of 7 equals -5. Now, I want you, for independent practice, interpret this using function notation. Do not speak. It says, find its initial position. Do not speak. Okay, Mr. Buhe or Ms. Parala, what are they asking for? Again, Mr. Buhe or Ms. Parala. Hurry up, please. You're holding the class behind. How do we interpret the question? Find its initial position. Buhe, are you there?
Yeah, my computer crashed and I just joined right now, so I didn't hear your question.
I said, how do we interpret the question? Find its initial position. Initial position. In function notation. What do I write in function notation?
I'm not sure.
No, it's not complicated, man. What symbol will you use?
Integral?
No. It just says initial position. Where is the integral coming from? Buhe, what symbol do you use for position? Hint. Should you use A, V, or F?
V?
For position, use the letter V. We've been doing math for the last 6 months. What symbol do we use for position?
S?
S. What do we write for initial? What value should, if time is, what should the time be when it says initially?
0.
0. What are you doing, man? Okay, guys, have they given us a starting value S of 7?
Yes.
And do we need S of 0?
Yes.
Okay, so Ms. Jin, what are you writing next step? So S of 0 equals? Ms. Jin. Ms. Jin, are you there? Again, you guys are muted and still bloody annoying. You're wasting class time. Ms. Jin, are you there? Okay, Ms. Sobrano, what are you writing?
I'm sorry, what was the question?
I said, what are you writing? We need S of 0. We know S of 7. Or are you lost?
I'm lost. Yeah.
Okay. Oh, okay. And then, Ms. Sobrano, ask yourself, and you're not attending office hours at all. How are you even doing your homework? Like, honestly, how are you doing your homework? I'm not scolding you. I'm just asking a genuine question. How are you doing your homework but you just refuse to attend office hours? I've begged you, I've pleaded with you, I've told you 100 times, and you just refuse to attend office hours. How are you doing your homework? I'm genuinely curious.
I mean, I take longer than usual.
No, it doesn't have to do with longer. Yeah. Guys, would you agree with me? If you are not able to answer the question, it doesn't matter if you take longer. Would you know how to do it if you take longer? Mm-hmm. That would make sense. Okay, Mr. Hernandez, what are you writing?
Would it be S of 0 equals S of 7 plus integral 0 to 7?
7 to 0.
See, boy, observe the lower limit, observe the pattern. It's tempting to write 0 to 7. It's 7 to 0. S dash of t dt.
Yeah.
Guys, what's S dash after all?
V.
Whoa, is that the graph?
Yes.
In simple language, are we basically finding the area under the curve from 7 to 0? Is everybody following the lesson? I'm tying up a first semester concept. By the way, S of 7 was given to be -5, correct?
Yeah.
Plus integral 7 to 0 S dash of t, V of t dt. Is everybody okay so far? Okay, let's find the areas very quickly. Who remembers, stare at the graph. Who remembers the formula for area of a semicircle?
1/2 pi r squared.
So 1/2 pi r squared. So it's 1/2 pi. Stare at it. What's the radius of the semicircle? Obviously.
3.
3. Radius. I said radius. So what do you get? Simplify. What do we get?
9 pi over 2.
Thank you, Mr. Rango. 9 pi over 2. Next, we need the area till 7. So I'm dropping the perpendicular. Okay, what's the area of that rectangle?
3.
Three. Very good. Last step. Guys, slow down. Slow down. Are we going right to left or left to right? We're going 7 to 0.
Right to left.
Right to left. So smart kids, what should I really write?
Minus 3.
Minus
Plus
9 pi.
Okay, please be attentive to the order. Exactly, and that's how easy that was. Can you see I tied up a first semester concept with second semester concept with net change corollary? Okay, to another problem. Write down page 28, please. Tarango, are you getting more comfortable?
Yeah, I'm getting far more comfortable than I was in the beginning, that's for sure.
Okay, guys, read it with me. The volume of water in a drain is changing
At a rate?
At a rate.
So smart kids, what should you mean start writing?
A of T.
Let A of T be the
Amount
Of water.
amount of
of water.
water. I said this before, I'll say it again. The words volume, number, population, they just mean amount, okay? So she didn't say amount of the volume of water. Smartly just said amount of water. Okay, amount of water in the tank.
Measured in gallons.
Tank T, very good. Measured in gallons, because the amount is just being measured in gallons. And then A dash of T equals,
RT.
The art of T.
which is 3
On
over radical T.
a test, if we were to just start doing the straight without making the connection of A and T and A dash,
No. The AP marks you down for it, man.
Oh, okay.
Yeah, they want this work shown. The rate of change of the amount of water in the drain. Time T, measured in gallons. Oh, I did not say it. It's gallons per hour, by the way. That's page 28. I have to make corrections. Page 28. I'm writing on my palm, by the way. Okay. Guys, interpret this using notation. In function notation, I put a bracket. At T equal to 2, there were 10 gallons in the drain. Go.
R. Equal.
A of 2, not R.
Oh,
10 gallons. Observe the units. A of 2 equals
10.
10 gallons. Find the volume at T equal to 7.
A of 7.
Very good. Oh, they give you a starting value. So A of 7 equals
A of 2 plus the integral 7
A dash T D2
dt
and A dash of T is nothing but.
RT.
And finally, last step. A of 2 is given to be
As 10.
plus integral 2 to 7. Again, guys, Mr. Hernandez, you made an error earlier. This lower guy is this guy and the upper is that guy. Even if it's big and small. Can you see in the previous problem, the big number was on the bottom, but that's okay. Tempting to write the big number on top all the time. No, it isn't that way. Okay, and that's 3 over radical. Okay, this guy can be integrated by hand. In case you say, not every question do I want you to use a calculator. Let's just do the integration and then leave. What's the integral of 1 over radical monkey?
3 times 2 radical monkey.
Radical monkey over 1. Lower limit 2, upper limit 7. Stupidly simple. Okay. This is the big problem today. Okay, you have this on your homework. Right on page 30. Feel free to draw a skull. It's an extremely important problem. This is the big problem we're learning today. Now read it with me. Repeat. We're on page 30. Udman, sweet girl, you're doing okay?
Yeah, I'm doing good. I understand this well.
Bishop?
Yeah, I'm doing good.
Carlos, sweet girl?
I'm doing good.
Okay, everybody read the question with me. The number of ants in a colony is changing
At a rate.
Okay, let's get started. Let
A
Of T equal the number of ants in the colony.
exactly.
Colin.
At the time T.
T
And that's just number, okay? There's no units, okay? There's ants. And let A dash of T be,
the amount or the rate.
which is F of T. It's the rate of change. Don't be lazy. And it's given, it's measured in amps per second. Is that clear? Okay, now. Okay, read the problem with me. I'm putting a bracket so you can focus. If there are 45 ants in the colony initially,
A of 0 equals.
thank you. A of 0 equals 45. Okay, you're learning something new. Read it with me. I'm drawing a squiggle. Find the maximum and minimum number of ants in the colony. Find the maximum and minimum number of ants in the colony over the interval 0 to 6. So smart kids, from the first semester, what concept are they talking about?
Absolute
Max and min of A dash.
The absolute max and absolute min. Are we talking in short, simple language? Are we talking absolute max and min of A of t?
Yes.
Over the interval 0 to 6. So smart kids, from the first semester, if I want the absolute max or absolute min of any function, I'll jog your memory. We should consider
Endpoint.
critical points. And then what will we do with those points?
Evaluate them.
Evaluate. I love you. We'll evaluate the function. Let's do that together. So write down, consider endpoints and critical points of A of t over the interval 0 to 6. So what are your endpoints, obviously?
0 and 6.
0 to 6. Okay. Okay, from first semester, how do we always find critical points for any function?
Doesn't exist or equals 0.
No, say that again. How do I find the critical point of any function?
You set the slope equal to 0.
And you set the slope. A dash of t. Oh, well, A dash of t is nothing but
F.
Isn't that just f of t equal to 0 does not exist. Remember, we just focus on 0. Okay, now stop. Put your pencils down, go to Desmos, and give me the 3 critical points in that interval 0 to 6. Quick, on the double. Okay, graph f of t. Repeat, graph f of t. Quickly, I'm not doing it. Graph f of t. The other class did this themselves. And tell me what the critical points are, which is basically set f of equal to 0. There are 3 critical points we got yesterday. So call them out for me. Repeat. If you did not take it down, it's -1/2 x times sine of x squared over 3.
I got 3.07, 4.342, and 5.17.
Okay, say that again, but louder. 4 point.
342.
Okay, 5 point.
317.
Okay, I need just one more kid to confirm.
Yeah, that's right.
Okay, everybody, last step. Should we evaluate the function? Okay, for the weaker kids, we're evaluating A of t. Is that clear? It says max and min of A of t. So watch. We need A of 0, A of 6, A of 3.047, A of 4.342. Relax, it takes 30 seconds. Desmos doing all the work for you. Okay? And then we'll write a conclusion. Make a note. We'll make a conclusion as an absolute max. We don't have time to do it, but we'll talk about it. Okay. Oh! What's A of 0 given to me?
45.
45. Oh, we know starting value. I need A of 6. So what concept kicks in?
That change
Corollary. A of 6 equals
A of 0.
A of 0. Is that A dash of t is nothing but f of t?
Yes.
And then dt. And A of 0 is 45 plus integral 0 to 6 f of t dt. Is everybody okay there? Now let me show you how to do this very quickly on Desmos. Okay, let me show you how to do this very, very quickly. Stay with me. I want to share a different screen. So I'm going to stop presenting here and then start presenting here. Resume presentation here. Okay, everybody do this with me. Okay, go to Desmos. Okay, I want some smart, good Samaritan to call out, what is f of t again?
negative 1/2 t
Okay.
times
Okay. F of t equals. Oh, sorry. F of x. F of x equals negative half.
negative 1/2 sine x squared over 3.
3.
Nope.
Okay, we got. Okay, now that. Okay, was a of 0 45?
Yes.
Blah.
Yeah.
Integral. 0 to 6 was it?
Yep.
Yeah.
And f of x dx. Yes.
Yes.
Okay, write down your answer. 44.8829. I'm rounding the fifth decimal. 44.8829. Now observe the genius. Observe the genius. It's not tedious. Is the next guy a of 3.07? What was it? What was the value?
Yeah, 3.0.
3 point
0.047.
047. Look what I did. Look what I did. I just changed the top value. I just changed the top value. Write down your answer. 43.5008. So it's not tedious. It just looks tedious. Did everybody understand the shortcut? Just change the top guy. Okay, what is the next value we need?
3.342.
4.342?
Yeah.
Okay, it's 44.9999. Actually, it's 45. Okay, what is the next value? Write down 45. What is the next value?
5.317.
317. Okay, it is 43.5 again. Okay, and then make a note to yourself. I don't have time to do this. Make a note like absolute max off and absolute min off. Got it? Just write a conclusion. Make sure you write a conclusion. That's how easy this is. Okay, so the smart thing was we use net change corollary. Is that clear? So I tied up the concept saying, oh, okay, let's go back. Well, I think in the last problem of the day. If you attend office hours, I'll do this problem, but otherwise you're on the last problem of the day. Okay, in your notebook, write on page 33, please. Everybody page 33. Now, in your notebook, I want you to sketch this figure very quickly, 30 seconds. It doesn't have to be precise. I'll make it easy. This is negative 1, 3, 4. This is 6, and this is 7. Just draw a quick graph. Okay, do label these points. They're relevant for the question. Oops. My God, what just happened there?
Nice.
Whoa. Not much better. That freaked me out. Okay, and that's 7, 9. Again, just draw a good graph. Okay, smart kids, look at the graph. What do we label it?
H dash.
H dash. Thank you. It's there below. It says graph of H dash. Make sure you label it as H dash. We're almost done. We're like 2 minutes out. Okay, next. Read the instructions with me. Read the instructions with me. Okay, I'm going to pick it up here. The areas, read it with me, please. Guys, tell them, look at the board. Ignore your mom. Look at the board. Okay. It says the areas of the regions bounded by the x-axis and the graph on the intervals negative 1 to 1, 1 to 4. Don't write. I'm just showing you. 1 to 4, 4 to 6, and 6 to 7 are 6. So is that guy 6? 8, 5, and 6 respectively. Did everybody understand the interpretation?
Yes.
I'm labeling areas. They're giving you the areas already. Okay, now we're doing stupidly simple problems. Okay, do this with me. Copy on the question. It says find h of 1 minus h of 7. Okay, smart kids, what's the question we always ask ourselves?
Is there a mismatch?
Thank you. Is there a mismatch?
Yes.
Yes.
Oh, so what should I write? Hernandez, let me see if you understood. Hernandez or Guerrero, one of you can answer the question. What am I writing? Careful.
Integral from 7 to 1.
7 to 1. Love you, man. Again, everybody watch. The negative sign is on the bottom. The positive guy is on top. So 7 to 1, h dash of x. Oh, isn't this h dash? Isn't this graph h dash?
Yes.
In simple language, do I just need the area from 7 to 1?
Yes.
No, stop. Is that left to right or right to left?
Right to left.
Right to left.
Be smart. So tell me what to write.
Negative
plus 5 minus 8
5 minus 8 minus 6.
Was that pretty simple?
Yep.
Okay, next question. Right on page 34. Okay, copy it on the question. It's on the bottom. Okay, what is the question I ask myself?
Is there a mismatch?
Just made a mismatch. So what can I integral of h double dash as?
H dash
Dash
minus h dash 2.
and minus h dash 30.
Stop. Is there an integral symbol here that I find the area under the curve, or I just read the graph?
You just read the graph.
Everybody, there's no integral symbol anymore. And this is h dash. So what's h dash of 7?
9.
9. Very smart. She's just reading the graph. Minus, what's h dash of 3?
6.
6.
Was that a lovely problem?
Yeah.
The answer is 3. It's like a 5-second problem. Okay, last question of the day. Guys, last question of the day. Okay. It says if h of 4 is 5, write that down. Find the
Absolute.
and absolute. We did an example. Let's just type the concept. So we should consider.
endpoints and critical points.
So we'll find endpoints and critical points of h of x. Yes. So endpoints are. Oh, by the way, it was -1 to 7. By the way, okay. So are the endpoints -1 to 7?
Yeah.
Okay. Once again, time concept for first semester. How do we find the critical point of any function?
Its slope is equal to
H dash x is equal to 0. Oh, and this is h dash. This is h dash. So what are your roots?
1.
1, 4, and 6. What do we do last step with these guys?
Evaluate.
Evaluate. We need h of -1. Oh, and they gave us a starting value. So h of -1 equals
H of 4.
h of 4 plus integral
1.
4. Amanda, it's 4. The lower limit is the first guy. -1 h dash of x dx. And what was h of 4 given to be?
5.
5 plus, and for this guy, are we basically finding the area?
Yes.
Stop. Are we going right to left or left to right?
Right to left.
Right to left.
We want the area from 4 to -1. Again, if I remember right, this guy is 6, 8,
Yeah.
5, 6. Okay, so I need the area from 4 to -1. So what am I writing on my notebook?
-8.
-8.
-6.
-8 and -6. Which is what? -9?
Yes.
No. Can we evaluate all the others the same way? And find a conclusion?
Yes.
Everybody okay there? Okay, put your pencils down. I don't know, do you guys, and at least many of you, have actually a bit of fun today? Correct? It wasn't bad at all, right? It wasn't bad at all. It was almost like a puzzle. Can you see? We did questions like regular algebra problems. We did questions with graph problems. And we did net change corollary using word problems from the first semester. Okay, I'm just doing a 30-second review, then we leave. So we did net change corollary using a graph. We did word problems, max and min. Tying up concepts from the first semester, net change corollary, endpoints, critical points. And we did more problems by hand. We did the same thing, velocity from a graph, and so on. So we did a lot of review. Tarango, how are you feeling today?
Oh, I'm feeling so much better.
Okay, McDonald is not here today. McDonald, is he there? He's absent. Okay, Carlos, how are you feeling?
I'm doing good.
McWater?
I'm doing better today.
Okay, silly girl. Wouldn't you have done better if you had attended class yesterday?
Yeah.
Bergen, sweet girl, how are you?
I'm doing good.
Meena?
I'm doing good.
Parada, whom I never talk to?
I'm doing good.
Alphas, how are you doing?
Doing good.
Okay, Mr. Castaneda, is he here? Castaneda is not here.
He was here. I think he got booted off though.
Okay, all right. Now the two kids whom I almost never talk to, Mr. Poole and Mr. Ferguson. How are you chaps doing?
Good.
Yeah, I'm doing good.
Okay, all right, just checking. All right, love you guys. I hope to see you in Oxhouse. We'll do more interesting problems, but otherwise we can go. Okay, thank you so much.
Thank
Bye. Thank you. Love you guys.
I have a question.
Yeah, go on.
For page 28, it was the R of T. You know how we evaluated the A of T, A dash of T?
Okay.
It was just a simple like AP question. So if let's say I didn't write over 1, would they mark me down?
No, you're okay. I will just show you over 1 because I want to foster good habits, which is don't forget to divide by the slope, correct?
Yes. And
Yeah,
then there was another.
Yeah, I was just emphasizing that concept.
Okay.
No, the AP would be okay if you did not write it. You're okay.
All right, for sure.
Okay.
We're
okay otherwise?
I had another question, but I can't remember. Oh, okay. So if let's say I didn't write like the connection, the consider endpoints and critical points of, would the AP mark me down for that as well?
Oh, here's the thing. Some years they have, some years they've not. So I play it safe by showing the work every single time.
Okay, for sure.
Okay, just show the work.
Okay, and that's all.
Yeah. Are we good?
Bye,
Okay.
Rama. Thank you.
Thank you, Mr. Gastelum. Thank you, Mr. Rama.